And then once the Bitcoin block with the validity rollup block inside of it gets confirmed, then the rollup block is effectively confirmed as well. And in order to actually undo that block on the rollup, you would also have to undo the Bitcoin block that it was confirmed in. So the rollup gets the same level of double spend security or double spend resistance as every other transaction that's confirmed in that block.
Hey everybody, welcome back to the Blockware Intelligence Podcast. This week I have on John Light. John, welcome to the podcast.
Yeah, thanks a lot for having me, Joe.
Yeah, of course. So John, can you tell the audience a little bit about yourself if they don't already know you?
Yeah, sure. So I do Bitcoin research in my free time. I also do research as part of my job. I work on product management for a project called Sovereign. And I have been researching cross-chain Bitcoin protocols such as like atomic swaps, side chains, most recently Validity, Rollups, and other aspects of Bitcoin such as privacy, scalability, governance, basically just different problem areas or interesting aspects of Bitcoin that I've been attracted to over the years. And as a part of that, research endeavor, earlier this year, I received a grant from the Human Rights Foundation as part of their ZK Rollups research fellowship to produce a report about validity rollups and the benefits, costs, risks associated with bringing them to Bitcoin. And so in October of 2022, last year, I published the report at bitcoinrollups.org. And I think that's mostly what we're going to be talking about today is the report and maybe some of the conversations that have happened since it was published.
Yeah, absolutely. I think that was a great overview about yourself and the research that you've done. For like a very high level overview at first for maybe the audience that isn't very technical. I do want to get fairly technical, or at least as technical as I can get later on in the podcast. But I think starting now, it's like I want to kind of go back a step and say, okay, why can Bitcoin not scale all on chain? Like, why are we experimenting with various scaling solutions like what you've been researching, or Lightning, or things like Liquid or Rootstock? Why are we doing this to begin with?
Sure. So the fundamental kind of limitation for scaling Bitcoin is that we don't want it to become prohibitively expensive to run a Bitcoin full node, which is a piece of software that fully validates that the rules, the consensus rules of Bitcoin are being followed, such as, the owner of a coin has to either sign the coin with their private key or provide the correct answer to some cryptographic problem or script in order to spend the coins, or things like the Bitcoin inflation rate or supply limit. If it became prohibitively expensive for anybody to run a full node, then we could end up in a situation where only the most well-capitalized businesses and professional Bitcoin miners would be able to afford to run a full node. And there might be such a small number of them that they are either easily captured by a private entity or by a government, or they could just decide to collude together to change the rules of the protocol out from underneath everyone's feet. For example, to increase the total supply of bitcoins and print themselves a bunch of bitcoins. if nobody could run a full node, or nobody else could run a full node because it was so expensive, then nobody could like check and see if this was like happening or not. And so the network would become extremely centralized, and it effectively reverts to the old system, right, which is controlled by a very small number of people, and most people have zero, either very little or zero say in the rules of the system. And so it's about keeping a validation of the rule set accessible to as many people as possible, so that we have as many people as possible making sure that the miners are following the rules. And um, if if you wanted to just scale Bitcoin to support, the billions of people and machines that could possibly be using it simply through, layer one on-chain transactions, this would result in a ton of transaction volume, like hundreds of millions or billions of transactions per day. And it would very quickly fill up everybody's hard drives and exhaust the computing capacity to like just verify those transactions and keep up with the chain tip of the blockchain. And 99.9% of full nodes would very quickly just get eliminated from the network because they don't have the computational capacity to keep up with such large amounts of transaction volume. And so in order to think about how could we actually scale to support so many users, but without running into the problems that I described earlier, where the network becomes more and more centralized until eventually it just gets taken over by some centralized entity, we've come up with these other kinds of protocols that move some aspect of making transactions off chain. In the case of Lightning, we've moved like most of the activity related to making transactions off chain. You only have to do a transaction to open a channel and close a channel if you want to do a final settlement. And then maybe you have to do some on-chain transactions in the middle to like rebalance your channels, or open new channels. But the idea is that your on-chain footprint is going to be drastically reduced. Instead of having to do one on-chain transaction for every time you make a payment, you only have to do these on-chain transactions like once in a while. Like I've had a Lightning channel that's been open since like 2018 or 2019 or something like that, and I've never done anything with it, but I continue to make payments, receive payments, and it's I haven't had to do an on-chain transaction since then. And so that's kind of what Lightning gives you. And then there are other kinds of protocols that people have come up with, variants of payment channels or state channels. There are sidechain things, that was different sidechain protocols that people have come up with. There's the new like Fedi Mint, Chaumian Mint kind of schemes that people have come up with. State chains. There's all these different kinds of protocols that people have come up with the idea of like how can we move some or all of the activity needed to make Bitcoin transactions off chain. And Validity rollups are another protocol that have been invented that is in that spirit. And we can get into like how they differ from Lightning, which most people may be familiar with the basics of, and compare it to other protocols like sidechains. But yeah, that's kind of the fundamental limitation that we're facing, and like the motivation for coming up with these other protocols.
Yeah, I think that was very well said. Basically, we need to limit block space, or make it to where it's very cheap and easy to run a Bitcoin full node, so more people can be verifying and setting their own rule set for Bitcoin. So like you said, not one single entity or a small group of entities can change the rules and add inflation or whatever they want to do to Bitcoin. I think that was very well said. But yeah, I definitely want to get into what you were finishing up with at the end of that last sentence, how you're talking about, there's Lightning and then there's these other things. I think most people are probably most familiar with Lightning. Probably not everyone listening to this podcast like runs a Lightning node per se, but they're like familiar with the idea and like have maybe used it like in a custodial manner potentially, or they've at least seen videos of it. Can you break down the difference between like Lightning and rollups?
Yeah, sure. So the basic mechanics of Lightning are that users open Lightning channels with each other, and you can have outbound channels and inbound channels. Outbound channel is where you open a channel with somebody else. An inbound channel is where somebody else opens a channel to you. And then you can send money out of the channel. And then once you send money out of the channel, that also creates some liquidity capacity for you to receive that money back through the channel. So like if you open a channel for 100,000 sats, you send somebody 10,000 sats, like you send your channel partner or somebody that else in the Lightning network that's connected to them 10,000 sats out through your channel, you can now actually receive that 10,000 sats back. But those transactions that you're sending through the channel happen off chain. That transaction doesn't hit the blockchain. So you create this single on-chain transaction to open the channel, and then you can send off-chain transactions through that channel. And you're limited to how much money you can send through the network based on your channel capacity. In the case of the example that I just gave, you have 100,000, you start with 100,000 outbound Satoshi limit. So you can send up to 100,000 Satoshis outbound to somebody else in the network. If you send 10,000 Satoshis out, then now you have 90,000 Satoshis outbound capacity and 10,000 Satoshis inbound capacity. So that the basics of the network are you have these channels, they have a channel balance or channel capacity, and when you make transactions, they're happening off-chain. And you can only make transactions with people who you have channels open with, or other people in the Lightning network who your channel counterparties are connected to through they call it the Lightning graph, which is basically just a network of these channels. Rollups work quite a bit differently. So rollups are they don't use a channel architecture, but they use a blockchain architecture. And also, every rollup transaction, the data of the transaction gets stored on layer 1. Or let's say if it's a layer 2 rollup, then the data of the transaction gets stored on layer 1 in a layer 1 block. However, layer 1 full nodes don't actually have to execute or replay the logic of the transaction. They just store the data of the transaction, and the transaction actually gets executed by nodes on a layer 2, the layer 2 rollup network. So to contrast the user experience with Lightning network, with a rollup, a user will make a transaction that deposits their funds into the rollup, and so now they have an equal balance of coins on the rollup chain. And then once they have their funds on the rollup chain, they can transfer those coins freely to any other address on the rollup chain. So they're limited to how much they can send to people, of course, because their wallet has only so many coins in their address. But they have no limit in terms of how many coins they can receive. So like when somebody, to onboard somebody to a rollup, they don't even need to like have an account on the rollup. They just need to create a rollup wallet, give the address to somebody who already has funds on the rollup, and then they can receive money, just as if I was onboarding somebody to Bitcoin layer one. Um, and so that I think is a kind of fundamental difference in that, you have the rollup transactions, they have to be stored in layer one blocks. And then also you can receive as much money as you want on the rollup. You're not limited by these channel capacities. So it feels a lot more like transacting on layer one Bitcoin or any other blockchain for that matter. Another important difference that's maybe worth talking about is that Lightning transactions cannot really be any more complex than the types of transactions that you can make on layer one. So, and if in practice, they tend to be much more limited. So, like for example, we have, multi-sig wallets on layer one, but we don't have multi-sig Lightning wallets really. Like you just have a single key, um, and you're making just simple peer-to-peer payments. You can do some interesting things like hold HODL invoices, I think they're called, and things like that. But for the most part, they're just simple peer-to-peer payments. With Validity rollups, because it's a blockchain, you can do pretty much anything that you could do with a blockchain, and not just the Bitcoin blockchain, like the layer one Bitcoin blockchain, but any blockchain. Even without Bitcoin layer one actually knowing or being able to do those kinds of transactions itself. So for example, you could have a Zcash-like fully encrypted private blockchain that's a rollup that works and is built on top of Bitcoin layer one, even though Bitcoin layer one itself, can't do Zcash-like transactions. And that is enabled through the use of these validity proofs. So that all Bitcoin layer one needs is the ability to verify a cryptographic proof that the rollup block is valid, and the rollup itself could support any kind of transaction that the developer programs it to, as long as somebody can produce a cryptographic proof that the transaction is valid according to the rules of the rollup. That proof can be submitted to layer one. Layer one full nodes, they don't need to know how to actually execute those transactions. They just verify the cryptographic validity proof, and then they say, this checks out. We're gonna accept that into the block, or the cryptographic verification fails and they reject it. But so rollups also give you a lot more flexibility in that way, in terms of how you can store your coins, how you can transact with your coins. Whereas, like I said, Lightning is relatively limited in terms of the types of transactions that it can support.
Yeah, I mean that makes a lot of sense. So basically, you're saying that it's possible, or it makes sense that roll-ups provide not only just more scalability, but also like more increased privacy and potentially more increased programmability as well, which is interesting. When
Yep,
you mentioned the word like validity roll-ups, what is that? What does validity mean in the relationship to like regular roll-ups?
sure. So there are two main variants of rollups that have been invented. One is called an optimistic rollup, and the other is the validity rollup, which you might also hear called a ZK rollup, because some of the rollup validity rollups use zero knowledge proofs. Um, but when you hear ZK rollup, you can just think validity rollup, because they're all validity rollups. Um, and an optimistic rollup uses a fraud proof system, or a fault proof system, as they're more recently called, actually quite similar to Lightning, the Lightning Network, where in order to make a state transition or withdrawal from the rollup, um, you will, or the rollup block producer will propose a new block on layer one and say, I have this new block with this new state, and I would like to finalize it. And then there's a challenge period, which is a modifiable parameter. I think a lot of the rollups in production use like a week or 2 weeks or something like that. And then during that challenge period, somebody can come along and they can submit a fault proof which shows that actually that state transition was invalid. It does not conform to the rules of the rollup. So for example, if somebody were to submit a state transition that attempts to withdraw all of the coins from the rollup, even though when you actually look at the rollup blockchain, like on the layer 2 network, they don't own all of the coins on the rollup. They only own a fraction or maybe none of the coins. But they're trying to submit a state transition on layer 1 that says, hey, I want to withdraw all these coins. That would be in violation of the rules of the rollup. But layer 1 isn't directly checking right away. Layer 1 only checks if somebody comes along and they submit this fault proof claiming that that state transition is invalid. And if the fault proof resolves to true, like it is true that this is an invalid state transition, then layer 1 will reject that state transition and say, no, give me a new block, that a different block. But if the fault proof challenge fails, that meaning that the state transition was actually correct, then that block is finalized and the rollup can make forward progress and go to the next block, and all of those transactions are confirmed or finalized, however you want to call it. That's actually a lot like how Lightning works, because when you do an uncooperative Lightning close transaction, there is this like several days long challenge period where your channel counterparty could submit a proof that says, oh, they're trying to close this channel with an earlier state. Because like, let's say, your channel counterparty, they open the channel for 100,000 sats, they send you 50,000 sats, but then they try to close the channel with the state before they sent you the 50,000 sats for the full 100,000 Satoshi balance. Well, if that entire challenge period goes by and you don't challenge it, they're going to get the 100,000 sats, and then you're out 50,000 sats. And so, your Lightning node or some third-party watchtower that you've designated as a trusted third party to do this is going to submit this challenge or fault-proof transaction to the layer 1 Bitcoin blockchain and say, this person is trying to close their channel with an earlier state, and if you can get that transaction confirmed, then you'll stop that invalid channel closure transaction, and you actually get like all of the balance of that channel. So there's like a financial penalty associated with this, but it's a challenge response system. So you make a claim, you wait some period of time. If nobody challenges the claim, then at the end of the challenge period, that gets finalized. But if there's a successful challenge, then it gets canceled. That's the basic premise of how an optimistic rollup works, similarly to Lightning. A validity rollup is different. A validity rollup works more like a normal Bitcoin layer 1 transaction, where every state transition comes with a cryptographic proof of validity. in the case of a Bitcoin transaction, the cryptographic proof is your signature, basically, along with the actual data in the transaction that Bitcoin full nodes will, they'll execute the transaction. Um, but with a validity rollup, um, it's not every single transaction that's getting confirmed, but it's blocks of transactions. So a bunch of nodes or users are making transactions on layer 2. Then a rollup block producer comes along, they gather all of these transactions, they bundle them into a block, and they might do some sort of compression on these transactions to make the data to make it a smaller amount of data, and then they'll pack this transaction data, all of the transactions that are in this block, into a Bitcoin layer 1 transaction, and then they will produce a cryptographic validity proof, basically running a bunch of computation that spits out this proof that says all of the transactions that are in this block are valid according to the rules of the rollup as originally instantiated on Bitcoin layer 1. And then they take this validity proof with the actual transaction containing all of the rollup data, and they submit it as a transaction to the Bitcoin layer 1 blockchain. And then layer 1 full nodes are going to check the validity proof. They're going to say, does this resolve to valid or invalid? And if it's valid, then they'll keep it in their mempool, and eventually a miner will come along and they'll pick up that transaction and they'll put it into a block. And so you can think of that as saying, like, of validity rollups have the same level of double spend security as a normal Bitcoin layer 1 transaction, which I think is pretty powerful.
Yeah, no, it's very cool and very interesting. You mentioned the idea of data compression, how like we would be, I guess, compressing the transactions on the layer 2 and the validity rollup back onto main layer Bitcoin. Are there like limits as to how much that data can be compressed? And if so, like what are there? What are your thoughts on that?
Yeah, so I think the smallest that I've seen rollup transactions get in practice is around 12 bytes per transaction. You can compare that to a normal like Bitcoin, um, let's say 1 in, 2 out transaction, which is a couple hundred bytes. And so you can get that down to like 5 or 10% of the size of a normal Bitcoin transaction. And if you actually apply the witness discount to that data, the SegWit witness discount, it gets even smaller in terms of weight units. So in my report that I published, I show how you can actually get throughput levels that are theoretically, like the theoretical maximum limit is around like 250,000 roll-up transactions per block, compared to your average Bitcoin block today, which is between 2,000 and 2,500 transactions per block. So the theoretical maximum is like 100 times your average transactions per block today, which is, again, I think that's pretty powerful. It's not like Lightning where you can do like unlimited numbers of transactions on this network, but you get full Bitcoin security, you get these extra features, and uh, you also get like 100 up to 100 times more transactions per block, which is I think would all be like a really huge boost to Bitcoin.
Yeah, I mean, 100x efficiency improvement, it would definitely be very interesting. Can you explain like the idea of validity side chains? Like, is that kind of the same thing as validity rollups, or not really? Is that like a totally separate idea?
It's a separate idea. They use similar technology in that they both use validity proofs to add some security to how the protocols work. But the main difference in terms of how I like categorize these things is that rollups require you to put like all of the transaction data that's happening on this other blockchain into Bitcoin layer one blocks, which fundamentally limits the throughput of that other blockchain. Because if the data doesn't fit in a layer one block, then it's like you just can't exceed that capacity. And whereas with side chains, you don't have to do that. There's no fundamental limit to how many transactions you could do, or the limits are like relaxed in terms of how many transactions you can do on the side chain, as well as like the rules of the side chain. Like it could be you could have 10-second block times, or hour-long block times, or you can certainly have faster block times. You can slow down a roll-up blockchain as well, but you can't really make a roll-up confirm blocks any faster than Bitcoin layer one, since roll-up blocks are actually confirmed in layer one blocks. Whereas with a sidechain, you could make a blockchain that has like faster block times. So you can do faster block times, and you have either relaxed or completely like technically unlimited throughput compared to layer one with side chains, because you don't have to put every single like transaction on Bitcoin layer one. It depends on the design of the validity sidechain protocol, and some protocols kind of blur these boundaries a little bit. Um, but that's mainly how I think about the differences between these two things.
Here's a quick message from our sponsor. Being involved in Bitcoin means you value freedom, financial freedom, freedom to save, and freedom to spend. Privacy, digital security, and no internet tracking logs are critical in the information age today. NordVPN is my favorite VPN service. It's fast, secure, and offers 5,500 secure servers in 59 countries. You can connect to any one of them and enjoy your favorite content no matter where you are. They've also doubled down on keeping you safe with their new threat protection feature. Say goodbye to intrusive website ads and malware. Even if you download an infected file, threat protection kicks in and deletes it before it makes a mess of your computer. The best part about this sponsorship, there's literally no risk with their 30-day money-back guarantee. Give it a try, and if you like it, great. If you don't, they'll issue a refund and you can pretend the entire situation never even happened. Check out our link, nordvpn.com/blockware, to get your subscription started today. Nice, yeah. Another kind of term that's been passed around more recently is this idea of drive chains. Like, what's the difference between something like a drive chain and a validity side chain?
So a drive chain uses a bridge that is known as a hash rate escrow. So the bridge is basically the mechanism that enables you to transfer Bitcoin from layer one to the sidechain and back. That's the most important part, probably being able to get your Bitcoin back out of the sidechain and onto layer one. And today we have these like federated bridges, we have collateralized bridges, we have centralized bridges. What DriveChain introduces is this concept of like the hash rate escrow, where it's a majority of miners, Bitcoin miners, effectively decide when to allow coins to come out of the sidechain and back to layer one. So like users would lock their coins in this script on layer one, the hash rate escrow script, and then their coins would appear on the sidechain and they can do their business. And then when they're ready to come back to Bitcoin layer one, they submit the withdrawal transaction on the sidechain. And then a sidechain miner is going to attempt to make a withdrawal from the hash rate escrow script on layer one and send the coins to the designated withdrawal address, or whatever withdrawal addresses they want, really. But the normal operation is that they send the coins that are being withdrawn to the specified withdrawal addresses. And then that transaction, that withdrawal transaction, then needs to get upvoted by miners for a certain number of blocks. In the Drivechain protocol, it's like 3 months worth of blocks need to upvote this withdrawal. Otherwise, the withdrawal eventually gets canceled and it doesn't happen. Now, the astute listener will notice that because the miners are deciding which withdrawals to approve and not approve, it also means that the miners could choose to approve withdrawals that are not valid according to the rules of the sidechain. So like the miners could collude with somebody or decide themselves, we're just going to make a withdrawal of all of the coins from this sidechain and send it to our address because we can. And that's the what I call the miners will steal hypothesis. Is that some people out there, they think because miners can do this, they will do this, and this is like a fatal flaw of the protocol. Drivechain proponents have a lot of like explanations about like why this won't happen. That mainly boils down to incentives, but this is like a capability that is like fundamental to the operation of the protocol. A Validity sidechain works a bit differently in that the withdrawals from the sidechain, instead of being controlled and approved by miners, at least explicitly through this like kind of upvoting process, instead withdrawals have to come with a validity proof, similar to a withdrawal from a validity rollup. And the validity proof basically has to say, this withdrawal came from some valid state that extended from the genesis block, the known genesis block of this sidechain. So like there's like a setup process where you make layer one aware of at least like the hash of the genesis block of the validity sidechain, and then the sidechain state can like progress off chain from there. And then when somebody wants to withdraw their coins from the sidechain, they have to produce this validity proof that connects that withdrawal back to at least a deposit of those coins, or if not, going all the way back to the genesis block. It's implementation dependent on like the exact rules of what exactly the validity proof needs to satisfy. But the basic idea is that you have to prove with this cryptographic proof that you own coins on the sidechain before you can withdraw them. And if you didn't own the coins, then you can't produce the proof, and therefore you can't get the coins out of the chain. And so they're not vulnerable to this same kind of miners will steal like problem that Drivechains are.
Yes, yeah, that made sense to me from a very high level for sure. Is there any like synergy between like Validity rollups and the drive chains? Like, is there anything that they can both like work together with, or are they just two completely separate ideas that can't really benefit from each other?
I think they are two separate ideas in that fundamentally what they are is a way to, what they both do is they provide a way to transfer Bitcoins to another chain and then back to Bitcoin. The differences are in how how the withdrawal of Bitcoin back to the main Bitcoin blockchain is enforced. With the validity rollup, it's enforced using the validity proof, and it's insured by this on-chain data availability. And with a drive chain, it's using this hash rate escrow mechanism. And the hash rate escrow mechanism is assumed to be like very secure because you have this large decentralized network of Bitcoin miners that are just kind of autonomously operating the hash rate proof based on very strong incentives that are built around Bitcoin mining and ensuring the value of Bitcoin and like the value of their ASICs and things like that. And so I think drive chain really only works if you build it like into a layer one Bitcoin or a layer one blockchain like Bitcoin. And also validity proofs or validity rollups rather. Um, like you want to do validity rollups on a chain that you consider to be extremely secure from both a hash rate perspective or a security budget perspective, as well as from a data availability perspective. And so in theory, you could build validity rollups on top of drive chains, but you would want to, only do that on top of a drive chain that had a very high security budget, had a very large network of full nodes to ensure data availability. And so I think in practice, you would probably not see validity rollups emerge on top of drive chains until you get one that kind of satisfies those criteria. And conversely, like you wouldn't really want to build a drive chain on top of a validity rollup unless the validity rollup was somehow secured using proof of work with a very large, diverse uh, network of miners who are unlikely to collude to steal from the hash rate escrow and have strong incentives to maintain the security of the hash rate escrow, and so on and so forth. And so, like, you basically need, in both cases, you need to build the protocol on top of a chain that looks a lot like Bitcoin layer one. And so I think that in practice, what this means is that we probably just want to enable one or both of these protocols on layer one, and it'll probably be a while, maybe never, before you actually see one of those protocols built on top of each other. So I'm not saying they're like strictly technically mutually exclusive, but in practice, they might be like mutually exclusive. Like as a user, you choose to use one or the other, um, depending on different use cases, but you're probably not going to use one on top of the other. Um, with that having been said, I think that the technology that validity rollups use, cryptographic validity proofs, could be used with drive chains. So, for example, you could turn drive chains into an almost like um, optional validity sidechain by having miners, layer one Bitcoin miners, run this validity client uh, or proof sync client next to their Bitcoin full node client. And the proof sync client would basically check all of the withdrawal transactions that people try to get confirmed on Bitcoin layer one. And just check like, is that transaction valid or not? Because with a proof sync client, what happens is that the the blocks of a given blockchain are actually uh, like used to produce a validity proof, so that you know that that block is a valid block that extends, from the Genesis block, and you can even add in, like a proof of difficulty so that you can compare blocks against each other and say, this one's part of a heavier chain than that one. And so you can pick the most heavy valid chain, and you can determine conclusively, cryptographically, that a transaction originated or was confirmed in the heaviest valid chain without having to actually replay all of the transactions. So you can imagine like a blockchain where every single block comes along with this validity proof that says, this block, and then every single block before it is a valid block that extends from the Genesis block of this blockchain. And with that, whenever you receive a transaction as a node that's just joining the network, rather than having to like sync your node and replay every single transaction from Genesis, you just get the latest block, the current UTXO set, and this validity proof that basically proves to you, you know, this is the current UTXO set. It is valid according to the rules of this chain, and the coins that you're receiving were being spent out of this known valid UTXO set. So miners, Bitcoin miners, could basically run this proof sync client that tells them, without having to actually execute all of the sidechain transactions themselves, it just tells them this withdrawal transaction is valid or it's not. And so they downvote all of the withdrawal transactions that are invalid, and they upvote all of the withdrawal transactions that are valid. And that way they don't have to run sidechain full nodes in order to resolve the question of like, is this withdrawal valid or invalid? Like this is kind of like one of the known, open questions in Drivechain is like, when there are multiple competing withdrawal transactions, how does the miner know which one to upvote and which one to downvote? And if they were running one of these proof sync clients, then they would be able to know at least which transactions were valid and which ones weren't, and then downvote the ones that are invalid and upvote the ones that are valid, without having to actually run a sidechain full node and like execute all of the sidechain transactions. So it keeps mining relatively low cost, instead of miners having to run full nodes for like every single sidechain that gets created to determine like which of these withdrawal transactions are valid or not. They just run this very simple, lightweight proof sync client. They check the validity proofs. They might hold like a UTXO set, which is a few gigabytes of data, and then it's like very lightweight to participate in the sidechain network and the Bitcoin network at the same time. So it is interesting to think about like how validity proofs could be used to used like as a complement to the Drivechain protocol, without actually building validity proof capabilities into Bitcoin layer 1 directly.
Nice. Yeah, that was very interesting, comparing the two and analyzing potential like synergies between the two like ideas and technologies. Um, Specifically around validity rollups, how has like Bitcoin developer interest been in just the Bitcoin community broadly, been around the idea and the research that you've put out?
Well, the feedback that I've received so far has, from the Bitcoin community, developer community in particular, has been relatively positive, I would say. We actually have a team that is working on uh, like a testnet, version of Bitcoin to add support for Validity rollups. And I've talked to developers working at different like Bitcoin companies as well as like volunteer developers about this idea, just like get their feedback. And it's been like mostly positive or just like neutral, like kind of wait and see approach to it. And yeah, I think people are interested in like seeing how they can um, support it with like other ideas that are going on, like around, for example, adding covenants to Bitcoin. They're thinking about validity rollups as a use case for covenants, because covenants are one of the like primitives that you could use to enable validity rollups on Bitcoin. And so the developers that are thinking about covenants are thinking about, if we do add covenants, like can we make sure that they support validity rollups? But there's a lot, not a lot, but there are a few other things that we would also have to change about Bitcoin in order to support validity rollups. And so there does need to be like a dedicated effort just for working on those specific things. Some people are working on it, but I hope to see many more people working on it because I do think that one, I think it's just a useful primitive to have on Bitcoin itself. But two, I think there are a lot of different things that you can do once you have this primitive. And so, people who are interested in scaling can work on scaling focused rollups. People who are interested in working on privacy can work on privacy focused rollups. Maybe those people can come together and figure out a, super scalable private rollup. People who are interested in programmability can work on like programmability rollups, maybe like a simplicity rollup or like a Clarity rollup or one of these other like smart contract languages that people have come up with. I think there's a lot of possibilities here, and like the big unlock, in my opinion, for developers is that you can build new features for Bitcoin without having to actually make changes to Bitcoin layer one. So you can, as long as we have like the verifier technology on Bitcoin layer one with the ability to like build validity rollups, you can just create a validity rollup that supports the new feature that you want to provide to people, and you don't have to actually like convince the rest of the Bitcoin network to adopt your feature. You just build your rollup, add the feature, and then roll it out to people. And I think that could be really powerful for experimentation. I think it would be really powerful for um, uh, any kind of new feature, like future in a way, kind of like future proofing Bitcoin, um, to consider like all of the possible things that users might want in the future that we can't even imagine today. Like it would be really great if we didn't have to change Bitcoin in the future when some really like important discovery or problem comes up. We can just do it on a validity rollup instead. I think that would be really cool.
Yeah, that seems definitely very appealing to me. The idea of like being able to keep the base layer constant and fairly immutable while providing that level of like, okay, we can still experiment and do certain things. I think that's very interesting. Last question, and then I think we can wrap it up. Um, Talking to other developers or talking to other people doing research on like the Bitcoin protocol, have they like brought up any like drawbacks as to implementing validity rollups or just the idea of validity rollups in general? Or are there any like sort of drawbacks that you've came across that like since you've done so much research on this topic?
Yeah, yeah. I actually included like a whole section in the report that was looking at like costs and risks. Um, and the the details of that are quite specific to your validity rollup implementation. So, for example, Bitcoin developers could decide okay, if we're going to add support for validity rollups to Bitcoin layer one, we don't want those Bitcoin, or we don't want those rollups to be any more powerful than Bitcoin layer one itself already is. Um, so like no new smart contracts, no new, fancy zero knowledge privacy stuff, just, simple Bitcoin, transactions. Um, and um, if they did that, then that would be very low risk, but it would also be quite limited in like its functionality. So you might get scaling benefits from that, but not much else. Um, and there's another perspective which says, depending on how you actually enable the rollups. Sorry, I
All
silence
good.
my phone and the alarm goes off anyway. I don't get it. Um, but yeah, so depending on how you actually enable the rollups, maybe you're using covenants as like one of your primitives. And there are some people in the Bitcoin community and in the the Bitcoin developer community who are opposed to generalized covenants or recursive covenants, which would be needed for um, validity rollups. And so, for the reasons that they would be opposed to adding recursive covenants to Bitcoin, they would be opposed to enabling validity rollups using recursive covenants. Because if you use recursive covenants to get validity rollups, then you kind of open the whole like Pandora's box of like what validity rollups enable, or of what recursive covenants enable. And so kind of beyond that, like if you had, let's say, I don't know, a Turing complete rollup that was built on top of Bitcoin, then maybe somebody builds a smart contract on that rollup that creates like a systemic risk to layer one somehow. I can't imagine like what that would be right now, but in some ways that's kind of part of the problem of like Turing completeness, is that you can do almost anything within the confines of like a gas limit and so on and so forth. But like you're it's very flexible in terms of the types of programs you could build, and so maybe one of those programs is somehow harmful to layer one, um, and so that would be bad. And so people might say, oh, because this is possible, like we might not be able to think of any specific examples now, but like it could happen that there's this program that's built on layer two and is somehow harmful to layer one, and we wouldn't really be able to get rid of it unless we like permanently censored that validity rollup, which involves intervening at the consensus layer on layer one, and it's like a whole thing. And so some people might be hesitant to enable those kinds of rollups. They might say we'll allow non-Turing complete rollups, but we won't allow Turing complete rollups. And so there's I think this like negotiation that needs to happen, as well as just like I think overall like a deeper like risk analysis, and thinking like, okay, if like starting from no limits, what can we think of as like the risks and the possible problems, and then as we like narrow down the capabilities and we get fewer and fewer like risks, like which risks are just unacceptable, which risks do we think are realistic, which risks do we think are um, unlikely to happen. um, there's just there's this process of like negotiation and prioritization of like what we actually want to enable with rollups that needs to happen. Um, and so, yeah, that's kind of, I think, the conversation. It's not really happening yet, but is I think a conversation that once there's like a real proposal on the table, or at least like a strong effort underway, those conversations are going to start happening.
Yeah, no, that makes a lot of sense. Where can the audience go if they want to learn more? Because obviously, we only had an hour to dive into a very technical, in-depth topic. Where can they go to learn more about, Validity rollups and potentially learn more about you and what you're doing?
Yeah, so they can check out the report that I published at bitcoinrollups.org. And they can also check out my blog at lightco.in. That's lightco.in. And on my blog, I publish a lot of research and opinions about Bitcoin, including on side chains, rollups, and other topics about Bitcoin that are interesting to me. And you can follow me on Twitter for my shorter form thoughts and musings at Litecoin, Lightcoin.
Awesome. Yeah, everyone go check out those resources. John, thanks for coming on the podcast. I think this was a very different episode from what we normally talk about, but I think it was a great episode for people that are curious to learn more about Bitcoin and how Bitcoin is going to potentially improve over time.
Great. Yeah, thanks again so much for having me, Joe. It was a pleasure to be here.